Okay, so we're looking at the distance formula today, and what we have to do in this problem is we have to find the length of this diagonal line here with the x on it. So first thing I'm seeing here is that we have a right triangle. If we have a right triangle, if we know these two sides, we can just use the Pythagorean theorem. And technically we don't really know these sides, but you can just count these boxes right here. Or you could look at this. 6 to 0 has to be 6 units. So this is 6 for that one. And on this side here, it goes from 0, 0 to 8, 0. That means it moves 8 units between those two. So right now, here's your a, b, and c. You just use a squared plus b squared equals c squared, the Pythagorean theorem. And you have 6 squared plus 8 squared equals x squared. Now to go through the math quickly, you'll see that x equals 10, where you square the 6 and the 8, add them up, and then take a square root, of course. So, cool, let's try another problem. This one is almost the same, except we lose the grid, so we can't actually just count these distances right here. We have to look at the coordinates, use these to figure out what are these distances right here. So let's look at this right here. It goes from 1, 6 to 5, 6. Obviously, these 6's stay the same, so like whatever, nothing happened there. But on the x-coordinate, it goes from 1 to 5. And in between 1 and 5, 5 minus 1 is 4. Likewise, if you look down here, it goes from 5, 6 to 5, 0. 5 stay the same, so like whatever. And then from 6 to 0, there's a distance of 6 in between those two things. So what you can do now is just solve using the Pythagorean theorem again. And x, the hypotenuse, is about 7.2 units long after you take the square root of 52. So basically what we're doing here with the distance formula, what we want is we want to work to a point of just given these 2 points here, how can we figure out how far this distance is? And if you look at it, remember in the beginning we did 1 and 5, and we figured out that one of these sides, or one of these things in the Pythagorean theorem, is 4. And on the other one, we looked from 6 to 0 and got 6. If you just look and focus on these 2 points right here, you can do 5 minus 1 and get 4. And you can do 6 minus 0 and get 6. And that's how you figure out what you plug into the Pythagorean theorem in the distance formula. So here's the distance formula. This is the fancy looking version of the whole thing. It's the square root of x minus 2, or x2 minus x1, squared, plus y2 minus y1 squared. So essentially, here's what you're doing. If you have these two coordinates here, you're going to take the x coordinates and subtract them. Right here, see? And you're going to take the y coordinates and subtract them. Use these two numbers, what you got subtracting, and plug them into the Pythagorean theorem. So you have like a squared plus b squared equals c squared, but in the end, remember, you're going to take a square root anyways. So this is the distance formula. The distance formula just is the Pythagorean theorem. That's all it is. There's no special tricks about it. And the way I like to do it is just subtract the x's, subtract the y, and literally plug it into the Pythagorean theorem. Don't even worry about this formula and like writing it all out or anything like that. So with this example, we're just given 2 points and we have to find the distance between them. So the way I'm going to start out is I'm going to subtract the x coordinates here. I'm going to do 5 minus negative 1. And essentially you can think of that as how far apart are those two numbers. And these two numbers are 6 units apart. And with the y values, you do the same thing. You can think like, how far away is negative 3 from 5? So if you do 5 minus negative 3, you'll get 8 units apart. So those are the two numbers you're going to use in the Pythagorean theorem. So to find the distance here, basically, the distance is going to be your hypotenuse. And then we have the change in the x and the change in the y for your a and your b. And your distance here is 10 units between those 2 points.